Hello, in this tutorial I will try to set up a model for KRATOS for open-ended pile installation in Choke. So I will just do File, New, and then I will select, I'm already in the data problem type PFEM, so this pops out automatically. It's an axis symmetric problem. So first I want to create my points. So I will create points which I've already pre-prepared. The geometry is taken from Alvarez's physical model. So you will see very small numbers as I type them in. So I have them down here. So 0 minus 0.00060. Then I have another point, 0.00347 minus 0.00060. Then let me zoom in because these are super small. Okay, and then I will add this other point just in case I need it. So 0.00 397 minus 0.00060, and then I have 0.00397 minus 0.0001, and then I have 0.0039700, and then 0.00700, and then 0.0270, and then 0.00500. Ooh, where did that go? Probably I did wrong. I will recreate this last point. So it's 0. So it should have been that 0.0500. I will delete this point here. I will have to find it. So point number 8 is, I will look for it. So it's x 0.005. I will delete it later. I did a mistake anyways. And then we go down to 0.05 minus 0.1350 over there. And then I go to 0 minus 0.1350, and then 0 minus 0.070, and 0 minus 0.050. Okay. So these are the points I created just because actually I have 2 more to create in order to have some zones that have a finer mesh. So I will put one in this location. So point number 5. So I have an x of 0.007 and the y is minus 0.050. Create point. Okay. And then I want to create another one that is in this location here. So it has an x of 0.027 at a depth of minus 0.090. Okay, it should have been at a different point. I will just create another one. It was 0.07. Okay, so I will have to geometry delete points. I want to delete this point here, and I also want to delete the point I created one at. It was 0. Did I create? Maybe I have two on the same location. Is it this one here? 0. Probably I have 2 points here. Geometry delete point. I put 2 points here. No, I didn't. Actually, that I didn't need that point there. So, okay. So now I can create lines. I will create lines joining the points. So this pops out and I say join. And then I go here, join, 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 join. Probably I should have just created the lines directly, but it's okay. We'll do it this way. So once I created my soil body, I also created this internal part, two internal parts. Perhaps this is, anyways, it's okay. It's just to have a finer mesh in this area and as coarser as we move out. I don't know why this. Oh, I think I delete lines. This model is, if it works, it's a miracle because deleting points and creating them is always a mess with JD. So so once we create the geometry here, okay, we want to create our solids. But first of all, I already know that I will have a curved point here, so that's why I created these two lines. So I can create an arch fillet curves. I'll try to fillet. So the radius of this arch is 0.0005, so half a millimeter, and I will create that. So, okay, it doesn't work because this is exactly 0.05. So forget about this, geometry, delete lines. I'll just delete them. Geometry, delete point there. I will actually create geometry. I will create a point in this location to create an arch passing from 3 points. So this location here is at the x should be actually I'll create a point up here. So the x coordinate of this point is 0.00347. Then the y coordinate is 0.0 0.04 0.004 and then okay, so then I geometry create an arc by 3 points and I have 1 join, 2 join, and 3 there join. Then I want to geometry delete lines. Oh, create arch by 3 points. Join, join, geometry create arch by 3 points. Join, join, and over there. Join. Then I want to do geometry, edit, divide lines. Near point, enter point near the line, that, and that. And then I press ask. Oh my goodness. Geometry, delete. You know what I'll do? Delete lines, that, and that. I will delete geometry, delete points. Yeah, you see I created too many points. This is messing up the project. Okay. Don't know why this point is not. Anyways, I'll continue. Please bear with me. You can put the video in front until I've finished this. Also, my wife is texting me to go home, but I believe this point is not there. I don't know why. I can do utilities, list, point. I can select that. It's in layer 2. Oh my goodness. I don't know why it's there. Let me just I'll delete that. I think it's because I tried to create that arch. My goodness. Anyways, I don't know if this will work. Repair model, let's see. Okay. Okay, I know. Okay, I had to repair the model. So let me add, let me draw a line like that so that then I can create an arch. So I will create a point. Actually, I will create a line from here, join to the point in coordinates 0, 0.00397 minus 0.0006, and then connect it to here, join. And then here I will geometry create arch fillet curves, enters the radius. The radius is 0.0005, and then 1 and 2. Okay, voila, we managed. Now I want to create a surface, so I'll create surface selecting 1, 2, 3. Okay, and then I want to create one that has these boundaries, and then one there. Oh, what is? Okay, so I have these 3 surfaces just because I will mesh, and now once we have created our geometries, we can start setting up our model. And we set our model by creating the solid part. Okay, so here we can see layers and groups. Okay, so I will start by creating my solid. So I double click here and I select solids auto, and then I want to select 1, 2, 3. These parts will be of the same solid material. Okay, and then I press OK. You will see this appearing, and in the groups you see solids auto 1. Then we don't have fluids rigid. Let's generate a parametric wall, a nose wall. So basically this is the open-ended pile. At the moment I will create, and you see it here, a nose wall. Okay, these are some instructions. I will make one and you will see it as it develops. So the center of our nose wall is actually this point over here. So the coordinates of the center are 0.00347. Then we have the y coordinate is minus 0.0001, and the z is 0. And then the radius is 0.0005. Rectangle is 0. The flank angle is 90. Okay. And then the length, I would say 0.1, 10 centimeters. And then 10 centimeters also. Okay. Let's just do 14 so that we can penetrate the whole model. Okay. And then I will call this pile. Throw, there it is, finish. So we see that that's our pile. It's over there and it will be a rigid wall. Okay, so it's over here and this is its properties. Okay, now we'll have one stage and then we have to go through all this to set up our model. I'll go back to my layer. So analysis problem type, it's going to be a geomechanical. Okay, then time of the simulation, I will have time steps of 0.5 starting from 0 till 6,800 seconds. This is just because I'm gonna move for 6,800 seconds at a given velocity so I can get to the position. But so the initial stress is constant. So of what? Well, we have to select the model part and we have a 0 because it's a small model. So gravity does not take into doesn't play a role. Then we have constraints. Let's see what type of constraints. Well, we have to put some boundary conditions on our model. So we will fix this boundary here, that boundary, and those boundaries, whereas this will be free. Now, also for Alvarez's problem, he had some sort of plate on top here that would not allow the displacements up here. So I will fix that as well. So let's start with, we want to fix in the X, whereas we can allow vertical displacement of this point, of this line here. So let's put a vector constraints, double click here. We want to put displacement. It's 0 in X, whereas it's free to move in Y. And then we want to select the lines, and then we want to select the line 1, 2, and 3. And press ESC. Okay, and we have to see these appearing here, vector auto. Okay, then we have the bottom one. On the other hand, we want to fix the displacement also in the Y. So we create, double click on vector displacements. We fix X, Y on this line and we select the bottom one. Okay, then we want to do the same on the right boundary. So on the right boundary, we want to have the same boundary condition of what we had on the left. So I will allow the vertical displacement to occur, and then I select this line here. Okay. And then on the other hand, for the top plate, it's free to move in the X direction, whereas the Y is free. So I double click, it's free to move. So I put none on the X. I select these 3 lines, 1, 2, and 3. Okay. Finally, we want to allow the displacement of the pile. So I will go on layers. I will switch off my layer and make sure that I'm on the pile. And then I put vector displacement and I give it a displacement load that has it's a function, so it's minus 0.0000. How many zeros? 1, 2, 3, 4, 5. 5 zeros. 1, 2, 3, 4, 5 to 9 times t. This is just the velocity that was assigned, and it's vertical on the lines, and then I select my nose wall lines. Okay. So now if I go back to groups, I can check it's assigned there. I go on layers, I switch it back on. So now we have all the boundary conditions apart from the water pressure, which is a scalar. So we want to assign a scalar water pressure. So water pressure at the top boundary, I will set assign 0, select to the top boundary lines 1, 2, and 3. Okay. I should have been on the layer. I hope this works, but anyways. Okay. So now we have no loads, okay? But we want to have, so there are no loads. We have a contact. We will have contact, yes. Select, so we have with a wall, okay? So composite wall, no, it's just one. The wall part is the pile. So the secondary part is solids auto. Contact search, yes. Body options is wall 1, and the contact options is, actually I would put elastoplastic, because if you put friction we need that, and then the criterion will be criterion 1, which we'll set up in a minute down here. Okay, then materials, we need for the solid surfaces and we select 1, 2, 3. Okay. And then we will set the material in a second. So let's set the material by putting data. I will do import, export materials. Import from file. I will put the structured clay, that is the Gens Nova. And then I will put it there. Okay. So now that the material is here, we can set the parameters. And I will just water density, the Young modulus. Actually, the Young modulus is 1, 2, 3, 4. So it's 1, 2, 1, 2, 3, 100 MPa. I believe so. Actually, it's 1 gigapascal. And then the Poisson is 0.12. The critical state line slope is 0.9. And then actually I will put it non-associated. So again, 1 gigapascal, so 1, 2, 3, 4, 5, 6 kilopascals, 0.12. Critical state line slope is 0.9. The plastic potential is 1.25. Friction angle, I'll just put 32 degrees. PS is 3000. PT is 300. Rho S is 19. Rho T is minus 15. XCS 0. XCT 0. 12.33. It's actually a quite permeable rock. Just do that. And then all these default are okay. So now that I've changed the properties of this structured clay, then I can tell to my material to be the structured clay, okay? And then we can move on to the remeshing. Yes. Steps 1, meshing to output, no. Meshing part, so we remesh the solids. Yes. Constraint, yes. Yes. Smooth mesh, yes. And smooth Jacobian, yes. Refine, yes. Refine options, so refine criterion, we will set the criterion down below, and then search boxes, no. Then the solution, we have time integration, quasi-static, nonlinear, type 0, element type. So default elements, we will have the updated Lagrangian UJ stabilized elements. And well, we don't have water, so we don't have to change that. Then we have non-local plasticity. Yes, so we will have for the solids auto a characteristic length. Now, the radius of this pile is 0.5 millimeter. So I'll just put a characteristic length of the radius of that pile, just in case. So 0.0005. Plastic volumetric strain, yes. Absolute plastic volumetric, yes. Plastic deviatoric strain, yes. Elastic volumetric strain, no. So solver setting, line search, yes. Line type is one is fine. Line search type 0 is fine. Implex, yes. So we go faster. And then the rest is okay. Convergence criteria, these are default are fine. The SLU with that tolerance, okay. We don't have any para configuration. So the results, so in mesh, let's see what are the customs. So on element stress, yes, von Mises, plastic strain. Well, I would like the incremental plastic strains and also the plastic strain. And then the stress invariants, I want to see them, yes. Porosity, yes. And then on the nodes, I want the displacements, the velocity. Well, not really. Acceleration pressure. I want the water pressure. Yes. And then I want the reaction force. Yes. And then the Jacobian. Yes. Good. So we need to define the refined criteria and the contact criteria. So the contact criteria is, I will use the penalty method. Well, penalty parameter, yeah, we can reduce a bit this value. I would just put 20, and then friction, yes, and then I would just put 0.57. Okay, so this is my criterion, and then I will do a refine criteria. So interior. So interior, I will use distance and threshold, and then coarsen by distance. And then the mesh, I should put distance only. And then the mesh size is, let's say, 0.000, let's say 3, and then plus non-local plastic deviatoric deformation, and then the threshold value is actually, I would put 1 e to the minus 9. And then at the boundary, I will just put threshold only. Distance, mesh size, I just put big. 0004. Okay. So now all these are, and then I would have to write save restart. Yes, I want the restart file. So we want to write the restart time step every, I don't know, we have 0.5, I don't know, every 100 steps. Okay, and then the output control step, I don't know, we can write an output file every, I don't know, 10 steps. Okay, so we will have actually every 20 steps. So every 20 step, it means every 10 seconds. We can change this later on, but anyways. And then option. Okay. So now I have to save, and I will call it Alvarez open-ended 28.9.22 rough. Okay, I'll save it, and then we have to mesh unstructured assign sizes on surfaces. So I want the 0.0003 in this middle part, so this will be quite fine mesh. And then I want assign this one maybe a bit not as fine, and then this one will be 0.06. Close, and then we can assign sizes here. Actually, let's see how this mesh looks. Control G to generate mesh. Okay. Well, this looks okay. Let's see how things go. So I can save here. I believe we have all the conditions are well imposed. I will save it and then cross my fingers and do calculate. Calculate. Did I forget something? View process info. Seems that. Okay, I don't know if there's an error going on. Did I do everything right? Did I forget something? Maybe it's because I have very many elements. Okay, it's working. So it takes quite some time because usually I never create a mesh that is already this fine. So such a big model, but I let it remesh. So in fact, we could have it, yes, a bit fine, but perhaps let it remesh when it needs. But yeah, let's make it calculate. So it will need, we said, how many steps to see the output? 20 steps. So we've done 2 steps. So I will let it go and come back to you when the steps are over to see what's in output. Because later on I will need to run the code from the command line because I need to include a Python script to read the load displacement curve. So I'll stop recording and come back to you later. Okay, I'm back. So we are on step 19. So soon, since we set that the output time step was 20, soon in the folder that you can see here, we will see as soon as the simulation goes on. Oh, what happened? The folder is there. Okay, step 20. So we'll soon see an output. So it's probably writing it now. Probably the mesh is too fine. This is taking ages. So let's try to close this now. We go back. Let's see if the output has written. I think that, okay. Window. Let's see. View results. Okay, so we see we have written one result in step 10. So we can display vector and displacement reaction. Actually, I wanted the contact force, so we can't really see that. So actually, we'll do contour fill and we'll put the PT, apply. So we see damage happening here, but this is just the first step, so it's going quite slow. Now I believe it's going very slow because of the very fine mesh already. So I think that we could actually decrease this region smaller. And so I will actually go back. And yes, I'm sure to go back. I will do edit load. Still waking up. So calculate. I will cancel the process. Yes, okay. Actually, I will show you how to quickly change the mesh. So if instead of redoing everything, I just move these 2 points over here. So if I do utilities, tools, geometry, edit, move point, I select this point here, and instead of being at a depth of 0.05, I move it to 0, and then I put, I don't know, 0.0. Actually, it was at a depth of minus 0 0.05. I put it to a depth of minus 0.02, and then I also move that from it was 0.5 was from 0.07 to minus 0.02. Actually, no. Let's see if it works. Minus, so it's 0.007 and then minus 0.00, 0.02. Okay, hopefully this would work. So if I do this and then I do mesh unstructured assign on surfaces, I will put 0.03 assigned to that, and then 0.003. Our remesh criteria is what? So I'll put 0.04 assigned there, close, and then perhaps try to generate the mesh. Yeah. I hope that this messed up everything. Mesh. I think that I messed up that thing by moving the point. So if I close here, no. Let me reopen it. Okay. Geometry. Edit. Move point. This one here from, I will move it to 0 and minus 0.02. And this point here from 0. Okay. Once we have that, and then do mesh unstructured assign so 0.0005. Maybe we can put 0.04 here. Okay, and then the remesh will happen as it goes in. So we have enough elements here at the contact. We could actually, make just mesh unstructured assign sizes on lines and put maybe 0.03 to this line, Okay. So if I now save here, actually I didn't like the results on the nodes. And then we didn't see the results. I didn't want to see the contact force. Yes. Reaction force. No. And then we can save. Let's decrease the post-process so we can see how things go. And then I save. Then I calculate again. I think that it will be faster. We have fewer elements. Actually, we could make these bigger, but let me make them bigger. Mesh unstructured surfaces instead of 0. Okay. Okay, let's see. It's a bit faster, you see. We have fewer elements. It will mesh there, but it was okay to have already some predefined stuff. Then as we move in and remeshing will happen down here according to the criteria. So here we are already at step 7. Okay, step 8, so it's going in step 9, so it's much faster because we have much fewer elements. So if we go on the output now, is we can do window view results. Sorry, this is my GID that is quite, for example, this way contact forces apply. Scale factor maybe of 1. Apply, we see the contact forces developing here. And then as the pile moves in. So we actually sit there. And then the mesh, we see remeshing happening 0.5. Okay, so we see that the mesh will deform, and then if we do contour fill, delta plastic strain, I mean it started, but it's soon we will start remeshing because we see that PT. Okay, so here I can actually open the process. Actually, I have to go to that 28.9. Yeah. Sorry, this is quite slow, but I'm just waiting for the window to pop out. Okay, PT contour fill. So we see it's happening, and I guess that we will have remeshing. I mean, we won't see a lot of remesh because the size of the elements is already small, but this is going in, and there is water pressure generated over here, so the permeability is quite high. So and so not really undrained process. So now if I go back, okay, I will cancel the process and launch it from command line, where I activate a Python script. Cancel process, yes. So okay, I'm going output just in case it's there. So in here, if I open the JSON file, this is the one I've just opened. I have various others here, but I will just get one where I have this. I just need to add this sum forces. So in problem process list, you need to add these lines in problem process list. So I will add this here. And basically this is the position of the shoulder. So it's the position of the corner of my, so to differentiate shaft. In fact, the shoulder should be minus 0.001. So below and above is the shaft. And so set this. If I save it, you can go and look at this sum forces process that is, I will just show you in a second, but then we go back to the folder. I open it on, and I will run I open a command line, and I will run pyx main PFEM. This will basically delete and restart the simulation, but we will see these forces appear is a CSV file that basically gives us the reaction force below and above my pile. With this, we can go back to Git and we can reload the solution. And I will just show you where the KRATOS application, PFEM application, Python scripts, and there is the sum forces SPATCAN. I originally developed where this is. You can see how this works. Good. I hope this was useful. Sorry it was long. Next time I will be more prepared and have it more detailed, but this is how it goes.